There is this really strange realization you hit when you've been working in tech or cybersecurity for a while.
Oh, absolutely.
Like you spend all this time auditing network traffic, tweaking your hypervisors, and, setting up biometric authentication, and you just assume you are in control of your machine.
Right. You think you have the final say.
Exactly. But what if the silicon itself, like the actual physical motherboard sitting on your desk right now, is running a completely separate hidden operating system?
Yeah, one that you can't see, you can't touch, and you definitely can't audit.
It's just wild. It's like obsessively locking the front door of your house while completely ignoring the fact that someone built a secret tunnel straight into your foundation.
It is honestly the ultimate blind spot in modern security architecture.
Right.
We spend so much energy worrying about software vulnerabilities, malware payloads,
That kind
phishing.
of standard stuff.
Exactly. We worry about all that.
Yeah.
And we often just take the underlying hardware for granted. We essentially trust that massive, opaque tech conglomerates are providing us with a clean slate.
Which is a massive leap of faith.
It really is.
Yeah.
Because if your hardware is compromised at the firmware level, or if it have intentional backdoors built in for, administrative convenience,
Air quotes around that.
right, then every single layer of security you stack on top of it is effectively built on quicksand.
Which is exactly why we are jumping into a massive stack of technical specs and architectural documents today for this deep dive. We are exploring the concept of absolute digital privacy and true hardware sovereignty.
It's a fascinating topic.
It really is. We are going to map out how you, the listener, can mathematically secure your data from the bare metal up. Whether you are trying to lock down your personal home office or, architecting a multi-million-dollar cryptocurrency exchange. Okay, let's unpack this.
The foundational shift here is moving away from blind trust. In a landscape dominated by supply chain attacks and zero-day exploits, your root of trust cannot live in a proprietary black box.
It has to be verifiable.
Exactly. It has to live on physical, auditable, open-source hardware. If you cannot independently verify what your hardware is doing, well, you don't actually own your device.
And we absolutely have to thank our sponsor, Nitrokey, for making this deep dive possible. They are the open source hardware pioneers actually building the sovereign ecosystem we'll be breaking down today.
They're doing some incredible work in this space.
They really are. And also a huge shout out to sponsor CISO.poker. If you are heading to the Besides LV, Black Hat, and DEF CON conferences this summer, they have an incredible event on August 5, 2026.
Oh, that's at the Wynn Las Vegas, right?
Yeah, exactly, at the Win. And CISO.poker is actually sponsoring both the third place prize pack and the final table prize pack. And for you listening, anytime we discuss the hardware architecture today, just know you can find all of it at securitygadgets.shop or direct. We've got all those links waiting for you in the description.
Perfect. So to properly understand hardware sovereignty, we have to start at the perimeter.
Right.
Before we even analyze the endpoints, your phone or your workstation, we really have to secure the environment where the data lives and the infrastructure it travels across.
And that immediately brings us to the next box and the NetROL series. Let's start with the next box, because I know a lot of people listening have probably looked into moving away from big tech cloud storage.
Yeah, it's a huge trend right now.
But I do have to push back a bit here. Pulling my data out of, say, an AWS or Google data center sounds great for privacy. But if I'm just throwing a Nextcloud on a Nextbox in my living room, aren't I just trading a privacy risk for a catastrophic data loss risk?
How do you mean?
Well, if the hardware fails, Google has massive redundancy across multiple continents. I just have a brick drive. How does this architecture actually solve for that without relying on a third party?
That is the exact right question to ask. The Nextbox isn't just a simple hard drive taped to a Raspberry Pi 4. It's designed to act as a sovereign node. So while you can configure it with robust local storage, you can run SSDs up to 2 TB or high-capacity HDDs up to 5 TB, plus 2 to 8 gigabytes of RAM. The real architectural advantage is how Nextcloud handles federated syncing.
Ah, so it's not isolated.
Right. And it handles encrypted local backups, too. You aren't just leaving a single point of failure in your living room. You can easily configure encrypted automated snapshots to a secondary local NAS or even an offsite trusted node. Plus, it's fully GDPR compliant with universal remote access.
So you're basically building your own redundancy, but you maintain possession of the encryption keys the entire time.
Precisely. What's fascinating here is how bringing the hardware on-premise fundamentally alters your threat model.
Because there's no middleman.
Exactly. By removing that corporate middleman, you instantly neutralize an entire category of attack vectors. You no longer have to model for, say, a rogue employee at a cloud provider.
Or a covert government subpoena demanding access to your data without your knowledge.
Yeah. Or a corporate policy shift that suddenly decides to scan your personal photos to train an AI model.
Which is happening constantly right now. So the blast radius is effectively contained to your physical environment. But obviously that data still needs to transit the public internet, which introduces the NitroWall appliances.
Right. Securing the network perimeter.
And for the advanced listeners out there, we aren't talking about a consumer-grade router that just nats your traffic and blocks incoming pings.
No, absolutely not. Devices like the NitroWall V1410 or the enterprise-grade VP4670 are heavily provisioned edge appliances.
Yeah, the specs on the VP4670 are insane for a firewall. It features up to an Intel i7, 64 gigabytes of RAM, Wi-Fi 6.
Right. When you are pushing traffic through something with that kind of massive RAM overhead, you aren't just routing. You are actively tearing down and inspecting packets at line speed.
Because it's running as a full intrusion prevention system.
Exactly. You are operating an active IPS at your network edge. Instead of just looking at headers and ports, the NitroWall is doing deep packet inspection. It's comparing traffic flows against known malware signatures, dropping malicious exploit attempts before they even reach your internal switch, and, handling heavy cryptographic lifting for site-to-site WireGuard or OpenVPN tunnels.
And doing all that without creating a bottleneck in your throughput.
Exactly.
And if you are an operator working in a highly hostile network environment, say a journalist in a restrictive regime or a penetration tester on a sketchy hotel Wi-Fi there, is the NitroWall NW750.
Oh, that is a fantastic piece of hardware.
This one specifically caught my eye because it acts as a mobile privacy router that tunnels everything directly through the Tor network. So it's not just encrypting your traffic.
No, it's actively bouncing it across decentralized global relays.
Right. So the local ISP sees absolutely nothing but encrypted noise, completely masking your IP and geographic location from the exit node.
It guarantees that your physical location and your network destination are cryptographically decoupled before the packets ever leave your immediate physical space.
Okay, so the perimeter is locked down, the transit layer is secure, but securing the network is completely futile if the endpoint receiving that data is already compromised at the silicon level.
Which happens more often than people realize.
We have to talk about the ghost in the machine. What happens when the threat isn't coming through the firewall, but is already baked into your CPU?
This is where we get into the Intel Management Engine, or the Intel ME. And for a lot of security professionals, understanding the Intel ME is a deeply unsettling moment.
Unsettling is putting it mildly. I mean, we think of our operating system, Linux, Windows, whatever, as ring zero, right?
Right.
The absolute highest level of privilege on the machine.
Right.
But the Intel ME is essentially ring next 3. It is a completely distinct, closed-source coprocessor embedded inside the main chipset.
And it runs its own proprietary operating system.
Based on M9X.
Right.
Yes.
And it operates completely independent of your main CPU and OS. It has out-of-band access to everything.
Wait, really?
Yeah,
Everything?
everything. The Intel ME can read your system memory, it has direct access to the network interface controller, and it can even power the machine on or off.
That's terrifying.
Well, it was originally designed for enterprise IT environments, so administrators could remotely provision or wipe fleets of laptops. So it was literally built to bypass the primary operating system entirely.
And because the codebase is proprietary and undocumented, security researchers can't fully audit it. So if a nation-state actor finds an exploit in the Intel ME, they can drop a rootkit into ringnext 3.
Exactly. Your OS won't see it, your hypervisor won't see it, and no endpoint detection software is going to flag it because the exploit is operating underneath all of them.
To me, leaving the Intel ME active feels like hiring a security guard for a bank vault, but then realizing he secretly works for the lock manufacturer and has his own set of keys that he won't let you inspect.
That is an incredibly accurate way to look at it. You cannot have hardware sovereignty if a closed-source coprocessor has ultimate authority over your machine. That is why workstations like the NitroPC 2 and the NitroPC Pro 2 are engineered to explicitly neutralize this threat.
They just shut it down.
They use specialized firmware flashing techniques to permanently disable and deactivate the Intel Management Engine. They are literally stripping out the unauditable code, ensuring that your operating system is actually the highest authority on the hardware.
But neutralizing the Intel ME is only half the battle. You also have to guarantee that your actual boot sequence hasn't been tampered with while you are away from your desk.
Which brings us to measured boot.
Exactly. This brings us to the NitroPad laptops like the V54, the V56 with 14th gen processors, and the rugged T480 and T480s models. They use measured boot combined with heads firmware.
Measured boot is honestly a masterclass in cryptographic verification. In a standard boot process, your UEFI hands off to your bootloader, which hands off to your kernel.
And if an attacker with physical access, like an evil maid attack, flashes a compromised bootloader while you are at lunch, your system will just happily boot up and hand over all your decryption keys.
But heads firmware changes the math entirely. As the NitroPad powers on, it mathematically hashes every single component of the boot sequence: the firmware, the kernel, the boot configuration.
And it stores those cryptographic measurements inside the TPM.
Exactly. And here is the physical verification step.
Yeah.
You plug your physical Nitrokey USB token into the laptop. The system takes the real-time hashes of the boot environment and sends them to the USB key.
Okay.
The key compares those real-time measurements against the known, trusted baseline you created when you first set up the machine. If the hashes match perfectly, the physical USB key illuminates with a green light.
But if an attacker altered even a single line of code in your bootloader, the hash changes.
The key flashes red.
Oh, wow. So you know instantly before you ever type in your disk encryption password that the machine has been physically compromised. It is hardware-level tamper evidence.
It brilliantly bridges the gap between complex cryptography and intuitive physical feedback. But even with a verified boot, you still have to run software, which inherently carries risk. That is why the NitroPC Pro 2 and the NitroPad V56 are explicitly certified to run Qubes-OS.
Now, I have to play the skeptic again here, because I know what you listening right now are probably thinking. Qubes-OS sounds great on paper, but the friction is legendary.
It has quite a reputation, yes.
If I use Qubes, am I going to spend half my day just trying to figure out how to copy and paste a URL from my email to my web browser? Like, does the security actually justify the operational overhead?
It requires a paradigm shift in how you work, undoubtedly. But for high-assurance environments, the friction is the feature.
How so?
Well, Qubes-OS doesn't rely on software sandboxing. It uses the XN hypervisor to enforce strict hardware-level virtualization. It isolates your applications into completely distinct virtual machines, or qubes.
So your network drivers are in one VM, your PDF viewer is in another, your crypto wallet is in an offline air-gapped qube.
Exactly. If you open a maliciously crafted PDF in your work qube, the exploit might achieve remote code execution, but it is mathematically trapped inside that specific virtual machine.
It can't break out.
Right. It cannot scrape memory from your banking qube, and it cannot access the virtual machine handling your network interface to exfiltrate the data.
Yeah.
So yes, you have to explicitly authorize clipboard sharing between qubes, but that friction guarantees that a single compromised application doesn't result in a total system breach.
Okay, so the desktop architecture is locked down tighter than a submarine, but desktops are stationary. The device we actually use the most, the one that travels with us everywhere, is the supercomputer in our pocket.
And smartphones are basically designed from the ground up to be surveillance tools.
Yeah. Mobile architecture is notoriously hostile to privacy. The baseband processors, the telemetry, the constant beaconing, it is an incredibly noisy environment.
Which brings us to the NitroPhone ecosystem.
Right. They offer everything from the entry-level NitroPhone 5A, which is great for fleet deployments, all the way up to the NitroPhone 10 Pro Fold and the NitroTablet 1.
They have a really solid lineup.
Now, these are built on Google Pixel hardware, but they run GrapheneOS. And again, the skeptic in me has to ask, I need Google Maps. I need my banking apps to authenticate my logins.
Sure, most people do.
Doesn't stripping out Google Play services with GrapheneOS essentially break the modern functionality of the phone?
It used to, but GrapheneOS has solved this beautifully through Sandbox Play services. You aren't giving Google root access to your device anymore.
Ah.
Instead, you can install the Play services as standard, unprivileged apps confined within a specific sandbox. They have no special access to hardware identifiers, IMEI numbers, or hidden APIs.
So your banking apps and push notifications still function perfectly, but the underlying OS is fundamentally blocking the telemetry that usually tracks your behavior across the device.
Exactly. And using Pixel hardware actually makes perfect sense when you look at the silicon.
Absolutely. The Pixel line includes the Titan M2 secure element. It is an enterprise-grade, physically isolated chip that handles rate limiting for password attempts and hardware-backed key store operations.
Right, and GrapheneOS leverages that Titan M2 chip to enforce a verified boot chain that is arguably the strictest in the mobile industry.
So you get the world-class hardware without the surveillance capitalism. But here's where it gets really interesting.
The physical modifications.
Yes. Nitrokey offers a hardware modification where they will physically desolder and remove the microphones, the ambient sensors, and the cameras from the device.
That's quite an offering.
But if I physically rip the microphone and camera out of a smartphone, is it even a phone anymore? It sounds like a highly secure brick. Who is that actually designed for?
It sounds extreme until you consider the specific threat models of highly targeted individuals. Imagine a C-suite executive involved in a hostile corporate takeover or an investigative journalist meeting a whistleblower.
High-stakes environments.
Very high stakes. If a nation-state deploys a zero-click, zero-day exploit like Pegasus to silently compromise the phone's baseband, they can activate the microphone remotely without the user ever knowing.
Because it's at the kernel level.
Exactly. A software toggle or a permissions screen won't stop a kernel-level hot mic exploit.
Right, but if the physical microphone literally isn't there on the motherboard, no amount of malicious code can make it record audio.
Precisely. To make a secure call, the user just plugs in a wired headset. The moment the conversation ends, they unplug the headset, and the device is instantly rendered deaf again.
That's brilliant.
Combine that with accessories like Faraday sleeves, which block all RF signals, preventing baseband tracking entirely, and data blocker USB adapters that sever the data pins when charging at an airport.
And you have built a holistic, high-assurance mobility suite.
Absolute control over the physical attack vectors.
Now, we have covered the home network, the workstation, and the mobile endpoint. But if this is the level of paranoia and architecture required for a single, highly targeted individual, how on earth does a massive enterprise scale this?
You mean like a cryptocurrency exchange securing hundreds of millions of dollars?
Yeah, exactly.
Well, when you scale to the enterprise, the stakes are exponentially higher. But the core principle of hardware isolation remains exactly the same. In a traditional data center, a server application holds its private cryptographic keys in system RAM.
Which means if an attacker gets root access to the server, they just scrape the memory, dump the private keys, and drain the crypto wallets.
Precisely. Software-based key management systems are ultimately vulnerable to OS-level compromise. This is why enterprise infrastructure relies on hardware security modules, specifically Nitrokey's NetHSM.
The NetHSM. That's a dedicated rack-mountable cryptographic vault, right?
Yes, designed specifically for data centers.
Yeah.
The root keys are generated inside the NetHSM's tamper-resistant silicon, and they never, ever leave that physical boundary.
So it fundamentally flips the architecture. The main server doesn't ask the NetHSM for the key.
No, never.
The server takes the raw transaction data, sends it over a secure TLS channel to the NetHSM, and the NetHSM does the cryptographic signing internally.
Exactly. The NetHSM calculates the signature in total isolation and only returns the cryptographically signed result back to the server.
I always think of it like a VIP, the server walking up to a bouncer sitting inside a bulletproof, opaque booth.
I like this analogy.
The VIP slides an unsigned contract through a tiny slot. The bouncer inside the NetHSM reads the document, stamps it with a seal that is physically chained to his desk, and slides the stamped paper back out.
Right.
The VIP gets the validated document, but they never once actually touch the stand.
If we connect this to the bigger picture, it means that even if an advanced persistent threat completely roots your primary application servers, even if they own the operating system and the hypervisor, they cannot steal the underlying keys.
Because they can't touch the stamp.
Exactly. The root of trust remains unbreached. Furthermore, unlike traditional HSMs that rely on proprietary vendor firmware, which might contain backdoor vulnerabilities, the NetHSM runs on fully auditable open-source firmware.
So you don't just have to trust Nitrokey.
Nope. Your security team can compile and audit the code themselves.
And this extends right into Nitrokey's consulting wing, too. They aren't just shipping hardware. They are helping high-risk Bitcoin startups map out multi-signature cold storage architectures.
The full-service approach.
They are working with enterprises to roll out FIDO2 passwordless authentication frameworks across thousands of employees, effectively neutralizing phishing at an organizational level.
Which is huge.
So what does this all mean for the listener? We have mapped out this incredible, mathematically secure architecture, But none of it matters if the supply chain is compromised.
Supply chain interdiction is a very real threat.
It really is.
You can architect the most brilliant NetHSM deployment or Qubes-OS workstation in the world, but if an intelligence agency or a malicious actor intercepts the package in transit and solders a rogue chip onto the motherboard, your network is compromised before you even power it on.
Which is why procurement strategy is just as important as the hardware itself. Now, Nitrokey is headquartered in Germany, which is fantastic because it offers massive EU privacy protections.
Yeah, they aren't subject to secret U.S. FISA court orders or NSL gag orders.
Exactly. But for US-based enterprises, international shipping means customs delays and extended physical exposure time where the package is just sitting in warehouses.
This is where utilizing an authorized, verified channel like securitygadgets.shop becomes critical for North American deployments.
Right. SecurityGadgets.shop acts as the verified U.S. distribution arm. Because they hold the inventory stateside, you bypass international customs entirely.
Which is a huge operational advantage.
You get fast 2-day U.S. shipping, drastically reducing the window for in-transit tampering. And for the IT directors out there, they handle enterprise procurement like purchase orders and Net 30 terms, and they actively map this hardware directly to NIST compliance controls to keep your auditors happy.
It ensures a hardened chain of custody from the manufacturing floor straight to your data center or your desk.
And there is actually an incredible opportunity to secure that chain of custody in person. SecurityGadgets.shop is organizing a special Vegas event batch drop.
That's right.
If you are attending the cybersecurity conferences this summer, you could reserve units by July 24th for secure in-person pickup right at the CISO.poker event in Las Vegas, happening August 5th and 6th at the Wynn.
That's a brilliant way to handle logistics.
And once again, a huge thank you to CISO.poker for sponsoring our third place and final table prize packs.
Procuring high-assurance hardware directly via hand-to-hand exchange at a major cybersecurity event is arguably the gold standard for neutralizing supply chain risks.
Oh,
You eliminate the courier entirely.
you really do. Well, we have covered an incredible architectural journey today. We dismantled the risks of centralized cloud storage and edge vulnerabilities with the Nextbox and NitroWall.
We really ran the gamut.
We did. We explored how to amputate the invisible threat of the Intel ME and enforce cryptographic boot integrity with heads on the NitroPC and NitroPad. We unpacked the reality of high-assurance mobility and hot mic threats with the NitroPhone.
And we scaled all of it up to the enterprise level, physically isolating root keys with a NetHSM.
It is a blueprint for reclaiming ownership of our digital infrastructure, proving that with the right open-source hardware, we can shift from a model of implicit trust to a model of cryptographic proof.
Which is exactly where the industry needs to head.
We want to thank you so much for joining us and exploring this architecture today. One final massive thank you to our sponsors, Nitrokey and CISO.poker. Remember, you can purchase all the hardware we analyzed today at securitygadgets.shop or direct, and we have those links waiting for you right down in the description.
As we wrap up, this raises an important question for you to mull over. If our hardware is mathematically locked down to achieve total data sovereignty, but our daily lives still require us to communicate with a deeply centralized, untrusted internet, does absolute hardware privacy inevitably clash with modern digital convenience? Where do you draw the line in your own life?